This is Computer Science Discoveries Unit 3, and this is Lesson 16 in the Designing Game chapter part of Game Lab. And we're talking this time about collision detection. So take a moment to look at this overview. All right, you're going to start investigating how you detect things touching each other or collision. Think about the video games you play. I mean, I'm going way, way back to something like Space Invaders or Pong, something like that. Whenever something touches, then there's some sort of reaction or response. All right. This is important for game design. So that's what we are going to work on now. In your vocab, 3 things. One is called abstraction. Abstraction in computer science or with computer science discoveries. Here they're talking about a simplified way to represent something more complex. You know, back in lesson 15, we talked about velocity. That took care of taking care of X or Y position and movement in one fell swoop. That made it a lot cleaner. So they often talk about this under the hood type thing. That's exactly what an abstraction is. Debugging, oh my goodness, we do that all the time as programmers. And just a reiteration of the if statement and how we have to use conditional statements to make things happen. New code you are going to see in this lesson is sprite.isTouching, and then it says target, which means you've got to know you have 2 things that you need to measure if they are touching each other. So you have the sprite and then the target itself and something about debugging. Awesome. Let's move on to level number 2. All right, here they say, look at the frog jumping game to the left. Let's run it. It looks like the game from the last lesson, but the frog moves the mushroom. Do you see what's happening when it hits it? What code do you think would help the computer know whether these 2 sprites are touching? Well, let's see. The mushroom is moving across the screen. That's an X thing. So it must have to know the X position of the frog and the mushroom to determine when it's supposed to kind of knock or tilt that mushroom over, right? All right, click on finish. Here we go to level number 3. Balloon. All right, let's see what's going on here. Oh, I have a balloon and I have like a push pin or some kind of tack. It says this code uses the sprite's X and Y position to check whether they are touching. It will change the balloon sprite's animation when the tack touches it. Use the arrow keys to move the tack until it touches the balloon. Now, they're saying we don't need to change any code. Just read the if statements in the draw loop, find the different sprite properties, how they're compared, blah, blah, blah. All right, so let's just do this. I'm going to run my arrow keys. There's up, right, left, and then finally down. They're kind of pokey, but I'm impatient. So let's see what happens. Pa-pow! Interesting. All right, now let's look at the code that they've got in there because somehow they're tracking what the thumbtack or the push pin's position is and the balloon's position, and then they change the animation of the balloon. So let's see what's going on here. I'm going to move me up out of the way a little bit so we can see what's going on. I've got the balloon. I'm going to reset this so we can see it. Balloon is right in the center. The tack is at 300, 100, so that's up there to start with. Then I look inside this draw loop, and honestly, I'm about ready to get sick because take a look at all of these nested commands in here. Holy mackerel. I've got this if statement that's just having to do with the X position. And then I've got this if statement that looks very similar with just the Y position. And somehow, if all of these conditions are being met, then the balloon gets popped. Wow. Below this is simply the commands that control the left, right, up and down arrows on the keyboard to move that thumbtack around. This is gross. Notice what it says, though, is that you don't need to change code. They just wanted us to look at this. I don't want you to get overwhelmed right now. That's not the point. There's something coming next that's going to make life a whole lot easier. So after you've had a moment to kind of look and digest that, pause the video, look at it, and then let's hit finish and go to level 4. Okay, so here's what happens. All of that code that was nested in there and got very complicated, writing all that math out every time you want to check to see if two sprites have touched each other can take quite a while. So, to make life easier, a programmer went ahead and created this is touching block. So as I scroll down here under the sprites toolbox, I see it. Yes, that's going to make all of that code that you saw in level 3 be kind of encapsulated. This is what we called the abstraction into this code. It can check whether one sprite's touching another, which is the target. The computer's doing all that math behind the scenes, or what they call under the hood, and you don't have to worry about it because someone else did all the work. So here's what we're asking you to do. Inside the draw loop, well, let's go find it. I've got the balloon and the tack again. Oh, it won't even let me run it because something's missing. Balloon, sprite setup, the tack is set up just like before. And inside the draw loop, rather than having all of that nested math commands, they are saying drag the is touching command into the if block. Okay, so now we have to check what two things are going to be touching each other. So they're saying change sprite to balloon. Here, change sprite to balloon, and change target to tack. So that would be the other thing. Okay. Now, that one line has replaced all of this code that was in the last one. Let's run this. Looks the same. Play around with it, move it around, see what happens. How? There we go. Stop there, play around a little bit, and pick up the next video to take you from levels 5 through 7.